Let's go.
Hello everybody, I hope everyone is fine and today we are going to discuss a question of circuit theory asked in GATE 2024 where a switch in the RL circuit is kept open for a sufficiently long time and the switch is closed at time t equal to 0. We need to find the time constant for the given circuit for time t greater than 0 when the switch is closed. In this lecture, I will explain about the entire transient phenomenon occurring in the given circuit. Over there, you will find the solution for the time constant and also there will be information about the inductor current. This is the circuit when switch is opened and the circuit is in steady state and the inductor is shorted. And this one is the circuit when switch is closed and for time much greater than 4 tau, where tau is the time constant of this circuit, the circuit is in steady state. If we look back to the earlier circuit, if we assume current I0 is flowing through the 4 ohm resistor, then double the current I2 I0 will flow through the 2 ohm resistor, as 2 ohm is half of 4 ohm. As we can see, both the resistors are in parallel and the voltage across them is same. So more current will flow where there is less resistive path. Since the voltage is same across both the resistor, so we can see I1 is double of I2. So double current will flow through the 2 ohm resistor. If we add both the currents I0 and 2I0, it has to be equal to 5 ampere. Hence I0 turn out to be 5 by 3 ampere. And this is the steady state inductor current for t lesser than 0. Before going to the main circuit, let's talk about some key point about the inductor present in a switching circuit. When switch is open in both the circuits, let us assume current I0 is flowing through the shorted inductor just before the instant of switching. In both the circuit, the value of I0 might be different. Once the switch is closed at t equal to 0, the inductor current at t equal to 0 plus must be equal to the previous current value I0 because inductor current cannot change instantaneously. At t equal to 0 plus, where current I1 is flowing through network A and I2 for network B, I1 0 plus I2 0 plus is equal to IL 0 plus equal to I0. During steady state, the inductor is shorted and IL infinite is flowing through the inductor. Let's again come back to the main circuit where switching occurred at t equal to 0 and inductor current at t equal to 0 plus is equal to I0, which is 5 by 3 ampere, and 5 by 6 ampere will flow through each of the 4 ohm resistor. At this node, at t equal to 0 plus, the voltage is 6.66 volt, and on the other side of the inductor, the node voltage at t equal to 0 plus is 3.33 volt. At t equal to 0 plus, the voltage across the inductor is 3.33 volt. But at t equal to 0 minus, the voltage across the inductor was 0. Hence, there is a sudden change in the voltage across the inductor. Therefore, there will be a gradual change in inductor current, and the deviation from the I0 is going to be dictated by the integration of the voltage. At a steady state, the voltage across the inductor again becomes 0 and the inductor current is IL infinity. There is a parallel combination of two 4 ohm resistor which reduces to a 2 ohm resistor. 5 ampere current flows through equal resistors, so IL infinite equal to 5 minus IL infinity. So therefore IL infinity equal to 5 by 2 ampere. It means for equal resistors in parallel, current will be divided equally in each branch, where each branch is containing the 2 ohm resistor. Further, this 2.5 ampere will be divided equally to the 4 ohm resistors. Hence, in the switching current, the initial current is 1.66 ampere and after the switching, the final steady state current is 2.5 ampere. So this is the waveform of the inductor current where T equal to 4 tau, and the inductor current will be 98% of IL infinity minus IL naught, where tau is the time constant. Once the switching is done, this part of the circuit experiences a transient. Let's reduce the parallel combination to a 2 ohm resistor and then calculate the time constant of this circuit. The equivalent resistance across this 3 ohm inductor is 2 plus 2, which is 4 ohm. Generally, to find the equivalent resistance across the inductor, we need to replace the inductor with a voltage source and find out the current flowing from that voltage source. Then the equivalent resistance across the 3 ohm inductor is equal to the voltage divided by the current. Generally, for a first order RL network where there is only one effective inductor, which is a storage element, the time constant is L by R equivalent. So here it will be 0.75, that is 3 divided by 4, and this is our answer. Okay. You can also visualize the switching circuit with a short circuit current of 2.5 ampere, which is our IL infinite, which is driving an R equivalent L parallel circuit where R equivalent is our equivalent resistance, where the L is 3. Also, the inductor was initially a current of 5 by 3 ampere. So if you solve the KCL across this node, then with this initial condition you will get a current equation. You will get this current equation when time constant is tau, which is equal to L by R equivalent. Now few basic point I want to discuss, that on a step input applied to the first order circuit, the voltage across this resistor will have no transient. So when the voltage is changed instantly after the voltage is fixed, so it will never have any contribution to the time constant. I mean to say, no contribution in the equivalent resistance in this first order circuit. Similarly, for this circuit, the current flowing through this resistor have no transient. So the input current is changed instantaneously, and the input will also, and when the input remains fixed, then the same goes with the resistor. The resistor will be also remain fixed. So there is no transient occurring across this resistor. So we should not consider this resistor for the time constant calculation. I am ending my video over here, and if you have seen my last video, do comment. Your feedback is important for us, and if you have any doubts, do comment. Your doubts will be answered once all the solutions of the analog circuit questions or some other circuit theory related questions for GATE 2024 are posted in our channel. If you have any doubt, first you go back to the video, see it again, and if still there is any doubt, please comment. Okay, I wish all the best to all my students. Thank you.